Hello, I'm Pushkar, Master Teacher in Chemistry at Vedantu, and I'm discussing KVPY 2018 SX Part 2 Chemistry paper. Here is a question. Consider the following reversible first order reaction of X at initial concentration X naught. The value of the rate constants are Kf is equals to 2 second inverse and Kb is 1 second inverse. A plot of concentration of X and Y as a function of time is. Four options are given. So let us try this problem. X is in equilibrium with Y. We start with X naught, initial concentration. After some time, it becomes X naught minus say X, and this becomes X. So at equilibrium, we have X naught minus X and X. These are the equilibrium concentrations, and this X divided by X naught minus X must be equal to 2 by 1. Why? Because K equilibrium is K forward upon K backward, that is equals to 2 by 1, which gives you X is equals to twice of X naught minus 2X. That gives you 3X is equals to twice of X naught, and that gives you X naught. X is equals to, that gives you that X at equilibrium should be equal to 2 by 3X naught. 1, you got this. And what are the equilibrium concentrations? So if you take X as to be 2 by 3X naught at equilibrium, what about this? That is equals to 1 by 3X naught at equilibrium, because this quantity is equal to this. So the net effect is the equilibrium concentration of Y should be double of equilibrium concentration of X. Do you agree? Equilibrium concentration of this should be double the equilibrium concentration of the equilibrium concentration of Y should be double the equilibrium concentration of X. So with these two clues, let's look at the option. The first option, that has decreased by considerable value, and I don't think that has decreased by 1/3 of the value. It doesn't look like 1/3. That's quite large. So there is a considerable decrease and there is a considerable increase in the concentration. It doesn't look like that Y by X is equals to 2 by 1. Okay, so this could not be the option. Looking at this option here, we can see that Y is at equilibrium is even less than X equilibrium. So it could also not be true. And in this case also we can see clearly that Y is quite less than X, and X is not decreasing at all. And whatever X is decreasing, this amount is decreasing, Y is increasing by the same amount. Y is increasing by the same amount. That's all right. But then at equilibrium, when this has reached equilibrium, the value of X equilibrium is less than value of Y equilibrium. That is not supported by the problem data. So only option we left with is the B option. Although it is not very perfect, because we can see this is the equilibrium concentration of X, and approximately it should be the double the value of this should be Y equilibrium, but then we don't have any other option. In four options, I think B is the most appropriate option. So let's go with the B, and that is our option. Quite a simple problem. Options are quite clear cut. So I hope that you understand this problem. Stay tuned for discussions of more questions.